pristine. Okay, we have to get this clear. So now if you look at this, you're like, okay, I can make the judgment what type of loading it is. Okay, it's going to be centric by knowing that the bending is only applied on one axis, right? The bending is only about one axis, right? You know it is what? Symmetrical bending already. Okay, symmetrical bending analysis. Okay, now any questions so far? Josh, thank you for participating. Okay, and I want all of you to learn. Okay, I want all to learn, able to identify what is symmetrical and unsymmetrical. Okay, it might not seem obvious when you do 2P, but over here you have to be very, very sure. Okay, now next I'm going to do one example. Okay, and this example over here is unsymmetrical bending. Okay, it's unsymmetrical bending. So we are going to do with this example over here. Oh. And I'm going to, so you have all these diagrams, okay? Right. You have a structure like this. Okay. So the couple moment is applied to a beam of the cross section shown in a plane formatting an angle beta with the vertical. Okay, so you have a 20 degrees. Determine the stresses at point A, point B, and point D. Okay, so point A, point B, and point D. And we are very sure for this case, right, is unsymmetrical bending. Okay, and I'll explain to you why. Okay, so this case, we have a case of, let me copy this image, and then I need this image quite a bit. Okay, so this is unsymmetrical, a condition of unsymmetrical or centric. Okay, we have a case of centric unsymmetrical bending, and some use why is that? Okay, this is because now some of you might say, Eugene, what are we looking at now? Okay, well, so this, for what we are looking now, this is the cross-sectional view. Okay, and I'll sketch for you. I'll sketch for you in 3D how this look like. Okay, so I'll try to sketch. So this is my X, this is our Y, and then this is our Z. Okay, so I'll sketch this out so it looks like this. Okay. So I'm going to cheat. No, I don't need this. Oh, it does not allow me to remove that. Really? Come on, Microsoft. Okay, forget it. Okay, so 2, 4. As engineers, we need to learn how to sketch, and I'm hopeless in arts, okay, so you can see how bad it is. Right. So, and then we have a moment, okay, doing this. Right, that is our moment. Okay, that is our moment. And if we were to label, this is our point A, this is our point B, this is our point D, and this is one point over here, which is our C. Okay, so you know what we are looking. So this is a condition of unsymmetrical bending. It's because now we have two, right? We have over here, we have our MZ, and then over here, now we have your MY. Okay. So now we know the direction, right? So we are going to have our right hand, we are going to apply our right hand rule. So on our right hand rule, what we have is, if this is our moment, right? If this is our moment, and we use our right hand, the thumb pointing up, and then we have a right hand, this is the moment vector, right? So this is going to be compression. This is going to be tensor. Okay. So in an exam or test, I strongly advise you to draw this, and then all you need to do now is to rotate or turn your page towards the right like this, and then you take your page again, and then you rotate. Okay, and this pattern always sticks, right? As you can see down here, something that is easy for you to do, and then you rotate it this way. Okay, so you will not be confused which is tension and which is what, compression, right? So if I'm going to now take this, right, if we're going to look at MZ, right, so okay, let's calculate MY and MZ first. Okay, let's calculate MY and MZ first. Okay, so from here, I'm going to push this up, right? We're going to calculate what is our MY. So MY is equal to 10 times 10 to the power 3 sine 20 degrees. Okay, so 10 power 3 times by sine 20 is equal to 3.420. Okay, 3420. Okay, pound inch. And then we know our MZ, 10 times 10 to the power 3. Now this is cos 20. Because this angle over here, we know is correspond to 20 degrees. So this is equal to cos 20 times by 10 to the power 3. And this is equal to 9397 pound inch. Okay. So what I'm going to do now, right? I'm going to take the moment vectors, right? So we know that over here, this is our moment about z direction. And then all you need to do now is you take this diagram, okay, and then you paste over here, and I'm going to compress it. And then when you align them, right, when you align to the axis, anything on top of the neutral axis, so I'm going to sketch the neutral axis. Okay, the green line is my neutral axis, right? So this is our neutral axis. And we know that anything at the top of the neutral axis for mz, this is compression. This is what? Tensor. So at point A, mz for point A is going to be in what? Negative compression. mz for point B is going to give us tensile. Sorry, let's not put minus for, it's going to be in compression. mz at point B is going to be in tensile. And then mz at point D is also going to be in what? Tensile. Are we clear? Okay, so you no need to worry about the formula. Okay, I'll write the general form of the formula. The general form of the formula states that stress in the x direction is equal to minus mz over izz multiplied by y plus by my over iyy multiplied by z. You don't need to know whether it's plus or minus now if you cannot remember. Just focus on the what? Moment vector. If you focus on the moment vector, you're good to go. You don't need to remember z positive or z negative. You don't need to remember all this at all. You already know from here. Are we clear? And I hope this helped you all in solving problem like this. Okay. Then the next one we're going to do, we know, okay, we are aware that from here, right, this is our moment about y. Okay, put a center down here. This is our moment of y. And assuming, I don't know yet, okay, I repeat again, I don't know yet where the central is, okay? So assuming that the central is the green line over here, then I just need to take this arrow now, okay, using right-hand rule, okay, take this diagram, and then I'm going to paste down here, right, I'm going to make it smaller. So based on my, right, what do we have? So based on my, we know that my, okay, from here, I can write my at point A is going to be in what? Compression. My at point B is going to give me compression. And my at point D is don't know because it's exactly at the what? At the neutral axis. But we have to find out, okay? Over here, we are very sure about the neutral axis. Over here, the neutral axis position is unclear. I don't know. We have to find out. Are we clear? We have to find out. So from here, as I've written before, the formula that we are going to use, is basically this formula that we're going to use. Okay, we are going to use this formula. Okay, now what do we know? What values do we know about this formula? I'll tell you what students made a lot of mistakes. And when we were grading the term test, we also found students making the same mistakes. Okay. The issue is the value of y, the value of z, izz, and iyy. Okay, some students still have issue knowing what is your iyy, what is your izz. Okay, and I want to, I know I'm repeating, okay, but I want to make it clear that it's not difficult to identify. Okay, so now going back to our diagram, now give me another 4 more minutes. Okay, we take a break at 8:50. We go for 10 minutes break. Okay, so now we're going to take this diagram. Okay, let me take this diagram again. I just want the diagram. Okay, and we are going to first find. Okay, we are going to first find IZZ. We're going to find IZZ. Now from here, the ZZ axis. Okay, so this is the ZZ axis. Okay, so we don't need to use we don't need to use we can, sorry, we just need to observe, okay, a line that we draw where the top half and the bottom half are the same. Okay, so we are very sure, right, that this line that I've drawn, this is our what? Neutral axis. Okay, we don't need to find, we know that is the neutral axis. The formula that we're going to apply is IZZ is equal to width depth cube over 12 plus by width depth, okay, big Y bar minus small y bar squared. For this case, okay, the big Y bar and the small y bar is equal to what? 0. Because this is where the neutral axis is. So we no need to find the what? We no need to use the parallel axis theorem. We only need to do with that cube divided by what? Divided by 12. Okay. So from here, the axis of interest is ZZ. Right? So we know that this is the what? This is the width. And we are also observe that this is the what? This is the depth. Okay, I'm going to stop here, go for a 10 minutes break, and we come back.